Solve problems on inventory model 1A with following characteristics. First, elementary model with deterministic demand. Second, shortages are not allowed. Third, demand rate uniform. Fourth, replenishment rate infinite.
Let us understand some important formulae related to inventory model 1A. Inventory model 1 is under the category of elementary model with deterministic demand. That means demand is fixed. And for this inventory model 1, shortages are not allowed. Now if we refer, it's a subtype for model 1, that is inventory model 1A. Then for this model 1A, demand rate is uniform, replenishment rate is infinite. Now we will understand some characteristics related to inventory model 1A. What is R? So R is inventory consumption rate, and inventory consumption rate is uniform. Then C2. C2 is cost of shortage. Now for this model 1, shortages are not allowed. So for no shortages, cost of shortage we have to take here as a infinity. Then C3, ordering cost per order. Then replenishment time is negligible. So what is the meaning of replenishment? That is to fill up the stock, and to fill the stock the time is negligible. Then replenishment rate. So because of this time is negligible, that is within no time replenishment is done. So replenishment rate we have to consider here as a infinity. And C1 is the holding cost or inventory carrying cost. Now we will understand this model 1A with the help of diagram. So here is the inventory level we have to plot on the vertical line, and on horizontal line there is time. Now we know that inventory consumption rate is uniform. So for this level, suppose we will consider here, this is the level of the inventory. So we will consider this point will be point P. Then consumption rate is uniform, so we have to draw here straight inclined line to show the consumption rate, and for the inventory consumption rate we will consider here R. So this inventory is consumption is there up to this point, so for this point we will consider here A, and from the initial point to this point A there is the time, so time we will consider here as a time period T. Now here is the inventory level. So what is the value of this inventory level? So here is the triangle PAO. So I will show here inventory level Q is equal to RT. So we can say that from this diagram, this is inventory level Q is equal to consumption rate into time period T. Now what is the stock? So stock, that means area of triangle OPA. So we will say that stock is equal to area of triangle OAP, which is equal to, so what is the area of triangle OAP? That is half multiplied by Q multiplied by T. So from this diagram we can write here Q is equal to RT and stock is equal to half into Q into T. We can draw here the next pattern from this point A, because at this point A all the inventory is getting consumed. Now here replenishment time is negligible, that is to fill up the stock there is no any time is required, and we have to fill the same stock, that is Q. So up to point P we have to draw here one vertical line from this point A. So here stock is fill up for this inventory Q, and within no time, that is replenishment time, that is to fill up the stock there is no time required. Now the same rate of inventory consumption, that is R is there, that is we have to follow for the same slope, and here we will draw here the same point, and from up to this point there is again the same time period T is there, that is we have to draw. So in the same way we can draw the next pattern. Now we will move to the formulas for the inventory model 1A. So first formula, optimal lot size, we can say economic lot size or economic order quantity, that is EOQ. So whenever there is optimal word or economic lot size is there, so we have to write to the base O, that is QO is equal to under root of 2C3R by C1. Then next, optimal scheduling period or time between orders or optimal time interval. So again for optimal time interval we have to write to the base O, that is TO is equal to under root of 2C3 by C1R. Then next is total optimal cost or minimum total cost. So for this cost also we will write C to the base O, which is equal to under root of 2C1C3R. Then next, total cost with non-optimal size. So this size is non-optimal, so we have to write only Q. So for this non-optimal size, how to calculate the cost? So whenever there is non-optimal size, then for cost we have to write Q by 2 into Ci plus R by Q into C3. Now instead of Ci, we can take here as a C1, because C1 is equal to Ci. Now what is this I? I is inventory carrying rate. Then what is this C? C is the purchase price. Then for order value, when it is mentioned in the question, that is order value, then we have to take CR, that is order value. Then N to the base O, that is number of orders per year. So how to calculate this number of orders per year? That is equal to 1 divided by TO, or we can also take R divided by QO. Let us understand the concept of lead time with the help of graph. What is the meaning of lead time? It is the time between order placed and order delivered. So there is some time. Suppose we will consider this time is in days. Now we will consider this total time period T is equal to 10 days and lead time L is equal to 3 days. Then how to plot this L? So here at this point there is inventory consumption becomes 0. So before that we have to plot the L, that is the lead time. So I will plot here L. Now from this point if I draw one vertical line, then here is the point of intersection. Now what is this line? So this is the line for inventory consumption rate, that is R. So we will mention here R. Then this vertical line is for inventory level Q. So we have to maintain this level Q. So when to place the order? Because there is the time gap in between placing the order and receiving the order. So if we observe, whenever this lead time L is there, then inventory consumption during lead time. So inventory consumption during lead time, that is this L multiplied by R, because this line indicates R. So inventory consumption rate, that is L multiplied by R. So when stock level becomes equal to LR, then we have to place the order for inventory level Q. So this is the reorder point. Then we can say that this point is the reorder point and notation is P. And its notation is P. So this is continuous review model because we have to review or continuous observing level of inventory, and when this level of inventory becomes LR, then we have to place the order. So when in question buffer stock B is mentioned, then we have to write the formula for P is equal to B plus LR. When D, that is the days required to review system, is mentioned in question, then what is the formula? P is equal to B plus LR plus RD by 2.
Given question, ABC Manufacturing Company purchases 9,000 parts of a machine for its annual requirement, ordering 1 month's usage at a time. Each part costs ₹20. The ordering cost per order is ₹15 and the carrying charges are 15% of average inventory per year. You have been asked to suggest a more economical purchasing policy for the company. What advice would you offer and how much would it save the company per year? This question was asked Dayalbagh Education Institute Agra MBA May 2013, SVSM PGDM 2009, PTU BE Mechanical May 2006, PU BCom April 2006, September 2004.
Let us understand the given data. Inventory consumption rate R is given 900 parts per year. Then time interval between orders. So each order is given during the period of 1 month. So what is the total number of orders? In 1 year there are 12 months. So number of orders in 1 year, that is 12. Purchase cost C is rupees 20 per part. Fixed cost or ordering cost. So that is mentioned. C3 is rupees 15 per order. Inventory carrying cost. So inventory carrying cost is 15% of average inventory. So here for this average inventory, purchase cost is mentioned. So we have to take 15%, that is 15 by 100 into 20, which is equal to rupees 3 per part per year. Now if we observe here, the inventory consumption rate is mentioned for a time period of year. So other units we have to take in the same time period, that is for year. Now we will find out what is the lot size, because we know that for 9000 parts total number of orders are 12. So for in one order, what is the lot size? That is 9000 divided by 12. So 750 parts. So here 750 parts are ordered for that is the lot size for one order is 750 parts, and this is ordered for a period of 1 month. So what is the total annual cost? So this is the non-optimal lot size. So here for this quantity we have to use this formula, because Q is the non-optimal lot size. So Q by 2 C1 plus R by Q C3. So Q by 2, that is 750 by 2 into C1. C1 is 3 plus R by Q. So R is 9000 divided by Q, that is 750 into C3, that is 15. So which is equal to rupees 1305. So this is the cost, that is the total annual cost. Now we will suggest that we can take here the chance for the optimal lot size, and we will calculate the optimal cost. So how to calculate the optimal lot size? That is QO, which is equal to under root of 2 RC3 by C1. That is 2 into 9000 into 15 by 3, which is equal to 300 units. So we have to order 300 units each time. Now to order 300 units, what is the total annual cost? So optimal total annual cost, we will calculate this by this formula. C to the base O is equal to under root of 2R C1 C3. That is under root of 2 into 9000 into 3 into 15, that is rupees 900. Now if we compare these two costs, so here is the total annual cost 1305, and here is the cost rupees 900. So we can say that if we order this optimal lot size, then we have profit of 1305 minus 900, that is rupees 405. And how many number of orders are there? Now out of total 9000 parts, we have to order 300 parts one time. That is 9000 by 300, that is we have to give 30 orders per year.
Given question. A stockist has to supply 400 units of a product every Monday to his customers. He gets the product at rupees 50 per unit from the manufacturer. The cost of ordering and transportation from the manufacturer is rupees 75 per order. The cost of carrying inventory is 7.5% per year of the cost of product. Find first economic lot size, second the total optimal cost including the capital cost, third total weekly profit if the item is sold for rupees 55 per unit. This question was asked NIIFT Mohali 2001, PU BCom September 2005.
Let us understand the given data. it is mentioned that stockist has to supply 400 units every Monday. That is, this supply is per week. So we can say that inventory consumption rate R is equal to 400 units per week. Then purchase cost C is mentioned rupees 50 per unit. Then the ordering cost, or we can also say fixed cost, C3 is rupees 75 per order. Then inventory carrying cost, that is C1, is given 7.5% per year of the cost of product. Now what is the cost of product? That is 50. So we can multiply here 7.5%, that is 7.5 divided by 100 multiplied by 50. Now this is the cost for per unit per year. Now if we observe inventory consumption rate, so this rate is given for week. So in 1 year there are total 52 weeks. So we will divide here by 52. Then it will become C1 is equal to 7.5 divided by 100 multiplied by 50 by 52 per unit per week. So when we simplify this, we will get rupees 3.75 by 52. Now we will move to the first question. So first question is, we have to calculate optimal lot size, that is Q to the base O, which is equal to under root of 2C3R by C1. So C3 is 75, C1 is 3.75 divided by 52, then R is 400. So if simply put the values, and when we calculate, we will get 912 units per order. So this is the optimal lot size. Then we have to calculate optimal cost with capital cost. So here capital cost is the important word. So this capital cost, we have to consider this purchase cost and this consumption rate. So capital cost, that is we can consider here C multiplied by R. So this is also known as the purchase value or order value. So order value, that is this C multiplied by R. So it's 400 multiplied by 50, that we have to add in the cost of basic formula, that is CO, is under root of 2C1 C3R. So C1 is known, C3 is also known, and R, that is also known. So when we calculate this, we will get the answer rupees 20,065.80 per week. So this is the optimal cost. Now if this unit sold at the rate of 55 rupees, then what is the cost? So when we sold these 400 units at the rate of 55 rupees, then the cost is 22,000. So how to calculate profit? That is this 22,000 minus this 20,065.80 rupees. If we take the difference, then we will get the profit.
Given question, the demand for a commodity is 100 units per day. Every time an order is placed, a fixed cost of rupees 400 is incurred. Holding cost is rupees 0.08 per unit per day. If the lead time is 13 days, determine the economic lot size and the reorder point.
Let us understand the given data. Inventory consumption rate is given 100 units per day, that is the value of R is given 100 units per day. So we will mention in this graph. So here is the inventory consumption rate R. Then lead time is also mentioned 13 days. So lead time, that is capital L, is equal to 13 days. Then fixed cost or ordering cost is also mentioned. So fixed cost is known as ordering cost and it is rupees 400. So we can say that C3 is equal to this 400. Then holding cost, that is rupees 0.08 per unit per day. This is also mentioned. So we will say that this is the value of C1 that is mentioned. Now first question is, we have to calculate economic lot size, that is economic order quantity, or we can say Q to the base O, which is equal to under root of 2C3R by C1, that is equal to 2 into 400 into 100 divided by 0.08, which is equal to 1000 units. Now we will calculate the time between orders. So how to calculate this time between orders? So we have to calculate this time for this lot. This lot size is 1000 units, and that for this lot our consumption is 100 units per day. So how to calculate the time between orders? So all this lot is getting consumed within 1000 divided by 100, that is 10 days. So we can say that TO is equal to QO by R, which is equal to 10 days. Now we have to plot this time. So this time is 10 days, that is all this economic lot is getting consumed within this consumption rate, that is equal to 10 days. So we will plot here, that is this T is equal to 10 days. Now we have to plot the lead time also. So this lead time L is longer than this TO. So I will plot here. So lead time we have to plot from this point, because at this point inventory level becomes 0. So from this time we will take here the one line, because it is longer. So we will take here this, draw here one line, and this L is equal to 13 days. Now we have to find out what is the effective lead time. So how to calculate? That is L minus TO, that is 3 days, that is 13 minus 10, 3 days. Now we have to show that. Now if we observe, this consumption rate will become uniform. So I will draw here the same slope from this point, because here also it will become 0. And now we have to maintain this level of inventory, that is up to Q. Up to this height we have to maintain. So I will draw here one vertical line. Now if we observe, here is the lead time. So I will draw here one vertical line. So this is the point. This point is known as reorder point. Reorder point, that is P. So how to calculate this reorder point? Because if we observe this effective lead time, that is this line is for 3 days, this slope is for R, then reorder point P is equal to this L multiplied by R. That is 3 days multiplied by 100, that is 300 units. So we can say that when our stock level becomes 300 units, then we have to order for the inventory level Q.
Given question, a company is considering a feasibility of changing suppliers for coupling hardware. Presently, the company has an optimal purchasing policy with S hardware at a discount of 1%. Current yearly purchases are rupees 81,000 and the administrative charges are rupees 125 per purchase, and the carrying charges are 25% of the average inventory level. Bids received from the other suppliers are: Nuts Cooperative offers 5% discount if ordered twice a year, and Grabbers Cooperative offers 3% discount if ordered 4 times a year. Should the company retain the present supplier or accept the proposed offers, and if so, which offer? This question was asked Dayalbagh Education Institute, Agra, December 2006.
Let us understand the given data. Discount is given 1%, 1 by 100, that is 0.01. So we have to consider the cost, that is 100 minus 0.01, that is 0.99. Then order value. So order value we will mention as a CR 81,000 per year. Fixed cost C3 rupees 125 per purchase. So this cost is fixed cost and the discount is not applicable to this fixed cost. Then inventory carrying rate. So here difference in between inventory carrying cost and inventory carrying rate, because this rate is mentioned 25% of average inventory. So average inventory word is there, and that's why we will say that this is the inventory carrying rate I, and that is 25 by 100. So we can write here I is equal to 0.25. Now we have to calculate what is the total cost by considering this discount of 1%. So for that we will first calculate what is the optimal lot size. So this is the formula, that is we will consider here its a unit is units. So if we observe q to the base o is equal to under root of 2c3r by c1. But if we observe the given data, c1 is not given. So we can replace this c1 with ci. So I will write here with red marker, that is ci. So under root of 2c3r by ci, and here we have to give that this in units. Now we will write here this optimal lot size, that is economic order quantity in rupees. So why to write this in rupees? Because this purchase cost C is not mentioned in the question. So we will multiply here with C, that is C into QO. So if I multiply here with C into QO, then this QO in units will become in rupees. So here whatever is the formula will become in rupees. So EOQ in rupees, that is C into QO is equal to. Now on left hand side we have multiplied with C. So on the right hand side also we have to multiply with C. But in square bracket we have to take this as a C square. So I will take here as a C square. Now same formula is there, but we have to take only C square in the square root. So 2c3r c square by ci. So c will be getting cancelled. So 2c3r c by I. Now this cr is known, then c3 is also known, and then this I is also known. So we will put the value. So c into qo is equal to under root of 2 multiplied by C3. So C3 is 125 into CR. So CR is 81,000 divided by I is 0.25, which is equal to 9,000. So this is the cost, because economic order quantity in rupees. So this is the economic order quantity, and this is the cost for economic order quantity, that we get the value. Now we will find out what is the total cost at 1% discount. So this is the cost only for the economic order quantity. Now we have to consider this fixed cost. We have to consider this order value also. Now remember, this discount is applicable for this economic order quantity cost and this order value only. This is not applicable for the fixed cost. So how to calculate this cost? So total cost at 1% discount. So remember, here discount is applicable. So we have to use the formula 1 by 2 C1Q plus C3 R by Q plus CR. So this is the formula that we have to use. Now we have to add it here CR extra because it is mentioned in the question. Now 1 by 2 C1Q. Now again same problem is there. C1 is not mentioned. So again we will write here CIQ. So if we observe this C and Q, that is CQO is 9,000. So this cost of economic order quantity 9,000 we can consider here, and I, that is 0.25. So how we can write this first part, that is half multiplied by 9,000 into 0.25, and for this 1% discount it is applicable for this, so we can write 0.99 because we have to refer here the 99% value out of this total value plus. Now this is for the fixed cost. So C3 R by Q. So again C3 is given, but here R is not given. So how to find out this? So here I will multiply and divide with C. Then it will become C3 CR by CQ. So CR is 81,000 and CQ, that is 9,000. So our problem will be solved, and C3 is mentioned, that is 125. So I have to write here 125 into 81,000 divided by 9,000, and here discount is not applicable, plus CR. So CR given 81,000 into 0.99. So here discount is applicable. So when we solve this, we will get rupees 82,428.75. Now we will find out the total cost at 5% discount. So same formula we have to use Q by 2 Ci plus C3 R by Q plus CR. But there is one condition mentioned. This 5% discount is applicable only when number of orders is 2 per year. So for this condition we have to take Q is equal to inventory consumption rate divided by number of orders, that is Q is equal to R by 2. Now we will replace this Q with R by 2 and we will rewrite this formula. So R by 2 into 2 Ci plus C3 R by Q, that is R divided by R by 2. So this 2 we will take in the numerator plus CR. Now we know that the discount is not applicable to this fixed cost. So we will apply discount to this first part. So if we observe C into R, CR is 81,000. So we will write here 81,000 divided by 4 into I. So I is 0.25 into discount 0.99 plus. Now this R is getting cancelled. So there is 2C3, that is 2 into 125 plus CR. So CR is 81,000 and discount is applicable. So here 5% discount, that means we have to take 0.95. So here we have to multiply with 0.95 because 5% discount, that means we have to refer only 100 minus 0.05, that is we have to consider 0.95 part of the total cost. So when we calculate this, then we will get the answer rupees 82,009.38. Now we will calculate the total cost at 3% discount by using the same formula Q by 2 Ci plus C3 R by Q plus CR. But here condition is given number of orders should be 4 per year. So for this condition we have to take Q is equal to inventory consumption rate R divided by number of orders, that is R by 4. So we have to replace this Q with R by 4. So again we will rewrite this formula Q, that is R by 4 into 2 into Ci plus C3 R by Q, that is R divided by R by 4. So 4 I will take in the numerator plus CR. Now if we observe the discount for the first part, discount is applicable and discount is given 3%, that is 3 divided by 100, that is 0.03. So the total cost considered is equal to 100 minus 0.03, that is 0.97. So we have to multiply with 0.97. So CR, that is 81,000 divided by 8 into I, that is 0.25 into 0.97 plus. Now here C3 into 4 because this RR is getting cancelled, 4 into 125. Here this is the fixed cost and discount is not applicable. Plus CR, so this is the order value 81,000 and here discount is applicable, that is 0.97. So when we calculate we will get rupees 81,525.31. Now if we compare the three costs with 1% discount, with 5% discount and with 3% discount, then this is the minimum cost. So company should take the offer with 3% discount.